in a uniform external field. An electric field is said to be uniform if the electric field strength at every point in the field is the same. Consider a permanent dipole of dipole moment P in a uniform external field E, which implies that P does not depend on E nor is it induced by E. The force on Q is QE and on minus Q is minus QE, and the net force on the dipole is 0. However, the charges are separated, so the forces act at different points, resulting in a torque on the dipole. When the net force is 0, the torque is independent of the origin. Its magnitude equals the magnitude of each force multiplied by the perpendicular distance between the two anti-parallel forces.
That is, magnitude of torque tau is equal to QE into 2a sin theta, which is equal to 2QA e sin theta. That is, tau is equal to PE sin theta, where P is equal to Q into 2a.
In vector notation, vector tau is equal to vector P cross vector E, where vector P and vector E are assumed to be in the plane of the paper. When electric field is not uniform, the net force will be non-zero, and there will also be a torque on the system. When P is parallel or anti-parallel to E, the net torque is 0, but there is a force on the dipole if E is not uniform. It is seen that when P is parallel to E, the dipole has a net force in the direction of the increasing field, and when P is anti-parallel to E, the net force on the dipole is in the direction of the decreasing field. The force depends on the orientation of the dipole moment with respect to that of the external field.